Hello everyone, this is James Shore with another test-driven JavaScript video. I'm recording this on February 12th, 2013. And when we left off in the last episode, we had just gotten our first set of basic touch event tests working, and I love it. I love being able to test touch events, especially since we're doing it in a cross-browser way. I really like how we've got this working on some browser, on testing on iOS Safari and skipping on the other ones. I really like this, and the code is pretty clean. We do a touch start, touch move, touch end, and then we expect the line segments to work in a specific way. It is pretty awesome. So what we're going to do in this episode is we're just going to continue on with that. We're going to clean it up. We have some other basic behaviors to test, and I think we're going to be done pretty soon. The first thing I want to do is to factor out the touch event guard clause. So you can see right now that at the start of each of our tests, we're saying, does it support test events? I don't want to do that. What we can do instead, though, is we can just skip the describe statement entirely in sort of a uniquely JavaScript-y way of doing it. We'll just say, if browser supports touch events, then we will do all this stuff. Like so. And that means we can get rid of that. And it means we can get rid of that. And I think we will still be good to go. Oh. So lint is complaining about something being used before it's defined. This used before it was defined thing has bitten me one too many times. I am turning it off. And that should solve the problem. And it does. All right. Back to work. So yes, it is now skipping touch events on browsers that don't support it, skipping testing touch events on browsers that don't support it, which is perfect, exactly what we want. So now let's see, what do we have next? Well, we've factored that out. Prevent default. So we need iOS Safari to not scroll up and down when we're drawing on the screen. And the way we do that is by preventing default. And we did this exact same thing with mouse events. So we are just going to steal that code. We're going to say, does not scroll the window when user is drawing with finger. Does not scroll or zoom the page. There we go. Yeah. And here we'll capture, let's say, touch start. Doing default prevention on start or move is good enough. And we'll expect that, we'll expect default to be true. And then we can just do that. And it should be that simple. Except we probably want this to be touch end. Great, it failed. That's what I was hoping for. Now we can fix this easily by just turning this back on. Excellent. Okay, what's next? Now we're moving. Okay, we've got some other touch events behavioral. We've handled the case where touch is canceled. We have prevented the default. We've still got the multiple touches to deal with, but let's just do a little exploratory testing first to see if it's working the way we think it ought to. So we'll say HTTP server, source client. Let's bring up this and, well, so far so good. Now, there's no mouse leave equivalent, but I kind of like this behavior where it just keeps on going when we're outside of the browser. And I think if we go out and then let go, yeah, it all works fine. And start and go in, can't even do it because of, yeah, it's working great. So, yeah, I'm pretty happy with this. I'm going to pause for a moment, try it with a real iPad, and see if I can find anything else. I'll be back in a moment. Okay, I'm back. It works great on a real iPad, and it's a lot of fun, and performance is actually really good too. I was worried that it might not be just because processor is not nearly as performant on the iPad as it is in my Mac. but everything seems really good. So the one issue that I found on the iPad, and it's one that's hard to test in the simulator, was the multiple touches. And we already knew about that from our spike. So we just need to deal with that, and then I think we're good to go. So yeah, we'll just get this multiple touches case handled, and then we are pretty much done. I think we have some cleanup to do, but that's it. So let's go ahead and get to that. I want to say it stops drawing when there are multiple touches. Now, right now, the real behavior of the iPad is that page X and page Y, which we're using, of course, to figure out where the line's going to go, that seems to be the sort of weighted average centroid, I don't know, of all the different touches that you're making. And that we don't want. So, and we could try to detect which touches are new and so forth, but I think it'd be simpler just to say, hey, if we're getting multiple touches, then the user has decided to stop drawing. So it stops drawing when multiple touches occur. Now the trick here is going to be testing this as usual. So let's say touch start 1040, touch move 520, and then let's say multiple touch move at 330 and 660, and then touch move to 10100, and that's where the touch will end. And actually what we'd see there is a multiple touch start, isn't it? Let's do both. Let's do a multiple touch start at 520, so we're simulating somebody putting a second finger down, and then we'll do a multiple touch move to, say, 110 and 770, sort of like them doing a pinch gesture, and then a multiple touch end at 770, or 110, 770, and then a touch move to 10100, and then a touch end at 10100. Now that may be overly complex, but I want to simulate a real behavior as closely as I can. Really, all we need to do is have it stop drawing when we get that multiple touch start. And so what we're going to expect to see here is a line from 1040 to 520, just like that. Now the trick is going to be doing the multiple touch start. Let's see, we'll need a relative x one. And then this is actually going to be a touch start event, and we'll pass all these through. And of course, we'll want to do the same thing for move and end. And none of this is going to work because we don't have a send multiple touch event. These variable names are pretty terrible, actually. But, you know, there's always the opportunity to improve them later, and I can't think of a better way to do it right off the top of my head. So let's go ahead and just pull all this over. If we do it exactly like this, except of course with relative 1x and relative 1y, then that will pass. But we don't want it to pass, we want it to fail. Oh, it did fail because it is behaving exactly the same, so it thought that this was multiple touches. So now, sorry, I was just looking at this, how to simplify it. I think we can just say multiple touch end ends all the touches, that will be easier to program. Okay, so anyway, now we need to deal with actually sending the multiple touch events. And I think the way we can do that is by having this be touch 1. That be touch 2. And the deal is that the next several events in this constructor, or the next several parameters, are touches, target touches, and change touches. And I think we'll just set all of those. So what we need to do is construct a touch list that contains the touches, and then we'll do it right there. And then we'll pass it through here. Touch list, touch list, touch list. That's what we're going to do, but we are out of time for this time. So next time we are going to, we're on the last touch event behavior. So what we're going to do is we're going to deal with multiple touches, and then we have some cleanup to do. But that, I think, will take us to the end of the touch event chapter. This has been pretty awesome. It's really built on the mouse touch, or the mouse event stuff we did. So I think we're going to be done pretty soon. So that's it for this time. Thanks very much for watching, everybody. I will catch you next time.